Earlier, I have spoken of a creative use of the flip solver, and that's what I'm going to attempt to do in this chapter. I will try to show you a few techniques and a few ways of controlling the flip fluid through pop forces. And hopefully this will give you a few ideas of how to use this tool to go beyond the basics and create more than just splashes or ocean surfaces. So I have created a very simple scene. I only have a curve and a camera. And I will start by creating another geometry node. I will call this Flip Magic. Dive into the node. And first of all, I will create a very simple emitter with a sphere. Make sure to change it to a polygon object. Increase the frequency to 20 just to have more detail. And then I will connect a flip source node. Okay, and I will add a null. I will change its color and call it out flip source. Now I will create a DOP network to start creating our flip simulation. And I will call this node DOP Magic. Dive into the network. Here I will create a flip solver. Connect it to the output. And I will also create a flip object and connect this one to the solver. Now, currently the domain is quite large, so I will go to my volume motion, change the size overall to 20 meters. And in my flip object, I will change the particle separation to 0.04, just to have a bit more detail. I will also go into the guides, particles, and change the visualization to particles. And in the initial data, I will remove this object because I rather have a continuous emission with the flip source that we just created. So I will add a volume source now and connect it into the sourcing input of the flip solver. So now I will go back to where I have my out flip source. I will copy this node and I will also create a bookmark here. I will press Ctrl 2 just to be able to come back here much easier. Dive into the DOP network and create another bookmark with Ctrl 3. And now let's paste the output of our source here under SOP path, and under initialize look for the source flip option. Now since we have no gravity, if we press play, nothing will really happen. Particles are being emitted here, but since they're all in the exact same position, we won't really see anything new. So go back to frame 1, turn on the real-time toggle. And last thing I'm going to do before I begin is channel reference my particle separation. So I will copy with right click. Go back to my source object and here on my flip source node, paste this value as a relative reference both in the voxel scale and in the particle separation. One thing I will also do is change the jitter seed to the frame value. So I will use the expression $F. This way, every time the frame changes, I will have a different jitter seed for the sourcing points. Okay, so let's go back into our DOP network, press number 3. And now we're ready to start manipulating this fluid with some pop forces. So since I'm going to use several forces, first of all, I will add a merge node. Connect it to the second input, the particle velocity of the flip solver. And let's start by adding a pop force, just to add some turbulence to this flip particles. So let's call this node turbulence big. And I will need to increase the amplitude. Let's start with a value of 5 and a swirl size of 4 meters. So I want quite a large wavy motion. And let's see what this does. So we have a constant emission from our sphere. Notice how we'll start to get some very nice waves from this turbulence force. And this is going to start looking very nice. So let me go back to my camera view. I will probably reduce the particle separation of my simulation just a little bit, just to make things faster. Go back to frame 1 and press play. And again, just by adding one single force, we start to have some very nice motion. Even for only a still frame, if you want to create some kind of illustration, you can create very nice and organic shapes with these techniques. So another thing that I will do is create a very strong drag force. This way I will have a more cohesive shape. So type tab, then pop, drag. Connect it to the merge node. And let's increase the air resistance to 4. Go back to frame 1 and again press play. So now we have the effect much more contained. I probably went too far, but again, it really depends on what shape are you looking for. And in this case, it's a matter of experiment. Since we're going for a more abstract effect, try experimenting the forces, the shapes, the size of the turbulence, and even add new forces to the simulation. So let's add a smaller turbulence. Actually, I'm going to decrease the air resistance a bit. Add another turbulence. So type pop, force. Call this one turbulence small. And connect it to the merge node. So in this case, I will use a swirl size of 0.5, an amplitude of 2, just to add higher frequency details. And let's see this through the camera.